hindsight, we did not give enough attention to the consequence element of the risk assessment.
Welcome everyone to the Industrial Security Podcast. My name is Nate Nelson. I'm here as usual with Andrew Ginter, Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and the guest of today's show. Andrew, how's it going?
I'm doing very well. Thank you, Nate. Our guest today is Eric Cosman. He is, among other things, he is the co-chair of the ISA SP99 committee. This is the committee at the the International Society for Automation that creates the IEC 62443 standard that is arguably the most influential industrial security standard in the world. And his topic today is stronger and faster. ISA/IEC 62443, how that happens.
Okay, then without further ado, here's you and Eric.
Hello, Eric, and thank you for joining us. Before we get started, can you maybe tell us a bit about yourself and about the good work you've been doing at the ISA and lots of other places?
First of all, I guess in terms of background, I am a chemical engineer. I call myself semi-retired. I have over 40 years of experience in the process industries. I'm now retired from my previous employment and a semi-retired and an independent consultant. I specialize in areas related to the application of information technology in an operations environment, including but not limited to cybersecurity. That's really where I spent most of my career. I've been involved in cybersecurity, operations cybersecurity now for over 30 years, actually, before it became, the popular topic that it is today. I started doing this internally in my company back in the late 80s, early 90s. And in 2001, I was one of the founding members of the chemical sector cybersecurity program under the American Chemistry Council. And I was on the team that developed the cyber security strategy for the chemical sector. At that time, when we were developing that strategy, we made the conscious decision that we would not develop standards unique to our industry. And that's what led me to an interesting meeting in Chicago in the fall of 2002, where we formed the ISA 99 committee. And so I've been on the committee since its inception, first as committee secretary and work group leader, and now for the last several years I've been the co-chair of the committee. And for those of you that aren't familiar with the committee, the ISA 99 committee is the principal authoring source of the ISA and IEC 62443 standards. And these standards are really the only sector independent consensus-based standards that define what's required for industrial cybersecurity.
So our topic today is the 62443 standards. I'm guessing everyone in the space is familiar with them to some degree. These are, this is sort of the standard everyone refers to in the industrial space. Can we start with what's new? What's changing in the standard? What's hot?
Yeah, it's a good question, and it's a question we get a lot. I'm very pleased to say that even though this committee has been in existence for 20 years now, we are still getting people coming forward expressing interest in learning more about what we're doing, and in many cases wanting to get involved. And that's I think that's a very positive indicator of the way that the industry views our work. Because we've been around for 20 years, there's a temptation sometimes maybe to think, well, there's nothing new going on. They're in maintenance mode, and they've developed the standards and so forth. That's not true. We have developed many standards and a whole series of standards and technical reports in this area. But as you know, this area changes constantly. So, and the nature of the threats change, the incidents that occur keep coming up and so forth, and people's understanding of the subject changes. So I summarize it by saying that we're sort of in the second generation, if you will. We've published several standards. We've got some more in the hopper to come out, but even the ones that are published now are either in or going into second editions. And in the course of doing that, we're focusing on consistency, internal consistency, because most of the standards in the series were developed, or the various standards in the series were developed by different people at different times under different circumstances. So the two recent developments that people might be interested in, we have actually formed a work group in the committee that we call a consistency group, and it's charged with taking a fresh look at everything that we have published or are about to publish and going through it with the proverbial fine-tooth comb to make sure that we are consistent. Because one of the questions that we get all the time is, what is the direction that the standards are giving me, and is it consistent both internally and with common industry practices? So that committee is very active and has also already come forward with a lot of very good recommendations for subsequent editions of the standard. The other development that sort of fits in with that, which is also a very positive one, at least in my opinion, is the IEC. That's the International Electrotechnical Commission based in Europe, has recently formally acknowledged 62443 as what they call a horizontal standard. And what that means is that committees in industry verticals, various industry verticals under the IEC umbrella, that are contemplating or considering developing guidance and standards requirements in cybersecurity are expected to build on the 62443 content. And that's very significant at the international level. I will say that in ISA, the International Society for Automation, in our committee that started the work, we've always worked with that assumption in place. We define the scope of our standards in terms of potential consequence, not in terms of a specific industry vertical. So we list a whole range of consequences, and we basically say that if your industry has the potential to have these consequences from a cyber incident, then this standard is for you. So it's nice to see the IEC picking up on that. And I think it opens up opportunities for us. Well, it already has, and will continue to open up opportunities for us to promote the standards in a whole range of industry sectors. And we've seen some examples of that already, and I'm really very optimistic that we'll see a lot more. So those are probably the two major areas we're focusing on right now. I guess I'd call it the standards are maturing. And there's one other one that I'll throw in just for laughs, and that is that we also have another work group that is devoted to answering two basic questions. The first question is, what are the implications of the industrial Internet of Things on industrial automation cybersecurity? And the second question that follows on from that is, how should the standards evolve to meet those challenges? And that group will be producing a technical report here very soon on that subject. So I'll leave it there and see if you want to follow one or more of those threads.
Andrew, I could use a high-level overview. So what are these standards that we're talking about?
They're standards for industrial cybersecurity. Some of the acronyms: ISA is the International Society for Automation. Their SP committees, standards process, I think, committees define a lot of standards for, the colors of alarms on human machine interfaces, on industrial control systems, for, the design of safety systems, a lot of industrial standards. The IEC is the International Electrotechnical Commission. So the the IEC is like the United Nations of standards. Nations appoint representatives to the IEC, and they create internationally recognized standards. So what happens here is that volunteers in the SP99 group of the ISA define the 62443 standards, and then they hand them off to the IEC that does a little massaging on them, but usually takes them more or less verbatim and votes and accepts them as internationally accepted standards. What are these standards? There's last I saw there was 14 or 15 of them either published or under development. And they got numbers. So 1-1 is, concepts and terminology. The one I'm most familiar with is 3-3, which is the requirements for securing industrial control systems. There's another one, I think it's 4-2, which is requirements for securing industrial control system components. Components like, programmable logic controllers, components like, Internet of Things devices. There's another standard on, doing security updates, patching. There's another one on risk assessments. There's, it's the most comprehensive set of industrial security standards in the world. Consider different industries. I mean, the consequences of a maliciously compromised railway switching system for a passenger rail system, the consequences can be immediate. They can be huge. They can be dramatic. Colliding passenger trains, hundreds of casualties. Public safety is at risk, massive consequences. Versus, and that's called an industrial control system. The consequences for an industrial control system in, let's say, a washing machine manufacturing plant, a consumer goods manufacturing plant. The plant might be 4 city blocks big with hundreds of machines in it. Each machine is, as big as a large room, or, sometimes bigger or longer than that for, conveyors. There's a lot of moving parts. Moving parts wear out. When you've got thousands of moving parts in a machine and something is not working, the technicians have to get, crawl into the machine sometimes to find the moving parts. This machine had better be turned off, or that, that technician is at risk. Or, a robot on an assembly line. If the robot goes crazy, well, everybody outside the yellow line, that's as far as the robot can reach, is safe. Everybody's watching, saying, someone should turn that device off before it hurts itself. The consequences are, in a sense, more constrained. An issue I've had with the 62443 standards is that I don't see them being applied consistently with this sort of knowledge of consequence. Somebody automating a coal-fired power plant with massive boilers and furnaces and, stuff that can explode, looks at the standard and says, okay, I must do this. I should do that. I might consider the other. And it's exactly the same words as somebody in the washing machine plant saying, I must do this. I should do that. I might consider the other. And, I don't see people applying the knowledge of consequence and using the standard differently in the different industries. And it really doesn't make sense to protect a railway switching system the same way you protect a washing machine robot. Is this something that, is this just me, not understanding things? What's going on there?
No, that's a very good observation. I share the same concern. In the standards, in our standards, we loosely define risk. I think we would all say that our goal is to reduce risk and mitigate risk, and we loosely define risk as being a function of 3 elements, and those are threat, vulnerability, and consequence, as you point out. And consequences really can only be determined by the asset owner. A consultant or a standard can't really prescribe or anticipate consequences of specific applications. So we make a very strong case in the standards that one of what we call the principal roles, we've defined several principal roles, and one and perhaps the first and most important one is the asset owner, and it's the asset owner's responsibility to define or identify potential consequences so they can apply the standards in a way that makes sense for their environment. And That's something we put a great deal of emphasis on, and we've seen some evidence of that as I mentioned earlier. We've had some um, early application of the standards for in say what were non might have been considered non-traditional or unanticipated applications. One of the first of those, and you mentioned rail, was rail. A colleague and a member of the committee in his consulting practice applied 62443 to rail transportation. And as you would expect, the consequences were different than you might find in a petrochemical complex or a refinery. But the principles of security are the same. It just, you apply them differently. And so this is one of the collateral benefits of this recognition as a horizontal standard. We're going to see more emphasis on this because one of the results of this horizontal designation is that there's going to be a formal recognition and formal activity around the development of what IEC calls profiles for specific industries. And they're beginning that effort in the IEC by developing a guide to writing a profile. And that one of the things that I hope that will, because the work is only beginning, but one of the things that it should address is if you're going to apply a generic standard in your industry, you need to focus on consequences so that it's part of your risk assessment exercise and your risk equation. So you are right. The consequences are an element of risk that, in my opinion, has not historically gotten enough attention. I've written quite extensively on this, papers and articles and blog posts on, trying to encourage asset owners to focus on this and not look for a simple prescription for cybersecurity.
Andrew, I'd actually like to question your original logic in your question there. I'm wondering why we need to consider consequences when it comes to regulation, how to do industrial cybersecurity. I know that we've had a lot of guests on, we've had a lot of discourse around consequence-driven sort of thought, but if the underlying principles are the same across a washing machine manufacturer and a coal-fired power plant, why shouldn't the rules on paper be the same? As a crude analogy, if I throw a football to my friend in the park, then there are certain mechanics by which I can get that football to spiral, to reach them in a way that's, satisfying to me. If I throw a football for the New York Giants in front of 50,000 people, then the principles by which I would throw that ball are functionally the same, even though the consequences of getting the ball to them, to whoever my receiver is, are much higher to many more people. So why is it different for industrial cybersecurity then?
Well, Nate, it really is all about risk. Which cybersecurity controls, to control risk, which controls we put in place have to do with how much risk we're willing to tolerate, how much risk we're willing to accept. And every, different industry, every different environment is, legitimately, accepting different kinds of risks. So, for example, let's say, the safety cutoffs on our equipment in a washing machine manufacturing plant are such that if a technician crawls into the machine, we've physically turned off the power to the machine. There's no possible computer hack that could affect safety in this washing machine manufacturing plant. What risk is left over? Well, there's a risk that, ransomware gets in there and encrypts everything and the whole plant has to shut down and we, spend 2 days erasing everything and restoring from backups. What does that cost? It might cost $1 million, $2 million. That might be a cost the business decides to accept because the cost of a security system might be $1 million a year as well. They might say, let's just try it this way and see how it goes because the cost of failure is acceptable. In the railway switching example, the cost of failure is completely unacceptable. You cannot afford, somebody get in there and mess with the tracks. And so you do legitimately have to put a lot of security controls in there to control that risk. If you've got different risk it demands different controls. And my question was about, that equation doesn't seem to be applied consistently, using the existing standards. And so, this is, Eric said, yeah, this is a concern. This is part of why we're doing industry-specific profiles.
Did you know that power plants are exempt from 1/4 of NERC requirements when those plants use Waterfall's unidirectional security gateways? NERC does not demand that power plants use the gateways, but the regulations recognize the strength of unidirectional protections. The regulations reward sites who use gateways by dramatically reducing the number of security rules for those plants. For details on the exemptions, please download Waterfall's latest report on the NERC standards. You can find the report on the waterfall-security.com website in the Resources tab under eBooks and White Papers.
You mentioned earlier, the standards are maturing. You're looking for consistency. One of the, another issue that I've observed and the standard I'm most familiar with is the 3-3, which is the specific recommendations. You should have this for your network perimeter and that for your host protection, and this for your security policies. In there is advice saying the minimum everyone should do is X. But then there's security levels as well. And the security levels are defined in terms of the capabilities of the adversaries. And, I don't remember them exactly, but it's, the way I think of adversaries, I think of them as nation states with almost infinite resources. I think of them as organized crime, which in the distant past, produced autonomous viruses that spread across networks and stole credit card information, back to script kiddies on sort of the one end where they don't know much, but they're too foolish to know how much trouble they're in if they download an attack tool and press the button. In terms of capabilities, the security levels are defined, and the advice, and this is an 8-year-old. It came out in 2013, 2014. It's an oldish standard. The threat environment's evolved. What we see is that what used to be nation state tools and attack techniques are today being used by ransomware groups. But the advice, the words in the advice hasn't changed. The word still says, if you've got a nation state coming after you, you should do this. If you've got, less capable adversaries coming after you, you really only need to do the other. And people don't seem to realize that the world has changed, and they're going to need to apply sort of the high end of the security advice to today's threat environment, because what used to be nation state is now commonplace. Again, is this something that is being addressed?
Yes. That's a very good observation. As a matter of fact, I mentioned in my previous remarks that we have several of our standards that have been out there for a few years, and I think your recollection of the year is approximately correct. It's around 2013. 3-3, 62443-3-3, which is the standard that addresses requirements at a system level. There is a corresponding standard in the 4 series, and I think it's 4-2, that addresses more detailed requirements at the component level. But 3-3 is currently under review for revision and creation of a second edition. We have an active group working on that. And your point about, the capability of the adversary, I have not looked at the document recently, but and again, this is my opinion, my observation, we need to express that when you're talking about that, you're talking about the nature of the threat. So, as I said earlier, if you look at risk as a function of threat, vulnerability, and consequence, the nature of the threat will vary depending on the perceived or demonstrated capability of your adversary. And it doesn't really matter. It's not really it's not a matter of, is it a nation state or is it a hacker group? It's how sophisticated are they? Because as you know, attribution in this space is extremely difficult. But what you can do is you can observe behavior of the attacker or the adversary, and you can make some sort of determination on how sophisticated they are. And you should ratchet your and you do this by looking at previous case studies and incident reports, and you should adjust your security level accordingly. Now, the one thing that and this has been an observation of mine, is that it gets back to my previous comment of consequence. In hindsight, when we look back, we did not give enough attention, pay enough attention to the consequence element of the risk assessment. So the group that's working on the rewrite of 3.3 combined with the consistency group that I mentioned earlier is right now, as we speak, looking at redefining our security levels to have a better mix of the threat component and the consequence component. And then, of course, that third component in the middle is vulnerability. And we know that vulnerabilities are always going to be there. And they're going to be a factor in determining risk as well, based on incidents. We know that if people report a 0-day, that gets a lot of attention because, by definition, it's a vulnerability for which no mitigation exists. So it's only by looking at the combination of all three that you can really sort of adjust your response. And that has to be very dynamic. You can't set a security level and think that it's never going to change. If all of a sudden if there's evidence out there that some adversary has suddenly started targeting your industry, then the threat element goes up, and you might want to up your security level, just as we see in the military world. I don't want to use the word DEFCON, but you know what I mean. You have to adjust that level.
It sounds like you're saying in the new 3-3, it would be reasonable to expect that many of the recommendations that used to exist only for security level 4 installations would drift down into 3 and 2 because the nature of the threat environment has changed. Is that fair? Or is that an oversimplification?
No, I think that's a fair statement. I do want to stress that ultimately the security levels that are listed in the standard are qualitative, and it is the asset owner's responsibility to determine ultimately how to characterize each level for their situation. And so, we give basically the security level construct in the standard says you should have different levels of security based on risk. And these are sort of in a general sense, how you would define them. But I think your observation or your expectation is reasonable. And I do want to put in a plug for the committee here for just a moment. We have a gentleman that works at Rockwell who's leading that group looking at 3.3. And if anyone who listens to this podcast has a passion for this space or wants to contribute and are either already a part of the committee or not part of the committee and wants to contribute, all points of view are welcome. So, if people, and particularly if they're based on practical experience, because we need experiential input as much, if not more, than sort of security theory. And so it's not a plug, it's more of a plea. If people out there are interested in contributing to this, I just want to let everybody know that we would love to have them.
Yeah, and I guess let me say something for the record here. I'm asking you questions about the standard. I hope people, don't get the wrong impression here. I've obviously been using the standard for many years. Maybe what I need to say is that I admire the standard. It's a tremendous effort. I admire the people who are contributing to the standard. I tried leading one of these groups at one point and got nowhere. I discovered that, in a sense, I'm the wrong kind of leader for that kind of group. It's hard to produce these things, and it's easy to punch holes in things. It's much harder to create something in the first place. So I have nothing but praise for the people who are out there creating this stuff. Now, nonetheless, I have some other hard questions for you, so I'm hoping I can get to them.
Yeah, go ahead. To your point, I understand your point. Standards of development is not for everybody. And so, it takes a certain kind of person um, to really persevere and particularly in a leadership role. But I don't want to discourage people who think if they have an idea, if they have a contribution, it doesn't have to be a labor of Hercules to get your contribution into the standards process. You can participate at whatever level is appropriate for you and your talents and your interests, whoever you may be, and and get your input in. And sometimes that input really doesn't take the form of active involvement as much as it is commenting on the standards as they are developed. But your point is well taken. I mean, as someone who's led this committee now for several years, we've all heard the phrase "herding cats," right? And it's a little bit like cat herding. One of the other metaphors that I like to use that's got an interesting visual attached to it in your mind is moving frogs in a wheelbarrow. It's a little bit like that too.
So just a word of personal experience here. I did try to lead one of the task groups that was producing a technical report on cybersecurity technologies at the ISA some years ago. And it was a big time commitment. It was, it was a skill set, the leadership that I'm not sure I had. It was just hard. What I'm doing today is commentary. I'm on the mailing list. When I see a draft come by, I make the time to read the draft top to bottom and give these people my very best feedback, typically between, 5 and 10 pages of comments. And of course, in between, in terms of time commitment, is the group that meets regularly and does the writing to produce the draft in the first place. So there are different ways to contribute here and to get involved. You touched on this a little earlier. You talked about, risk being threat times vulnerability times consequence. You talked about, standardizing terminology. A term that I've seen people trip over a lot of times is vulnerability. A lot of people, they say, look, if risk is threat times vulnerability and times consequence, if I can reduce my vulnerability to zero, I have reduced my threat to zero. Quick, patch everything. Because they interpret the word vulnerability to mean a software vulnerability, a defect in a piece of software that can be exploited. When in fact, I went back and looked at the definition a couple of years ago because, I was thinking this is just wrong. And sure enough, the standard defines vulnerability. I don't remember the exact words, but basically as any way that a system can be attacked. So yeah, software vulnerabilities are one kind of vulnerability, but there's lots of other kinds of vulnerabilities. And to focus on security updates, sort of exclusively or primarily is missing the point. But because of the term, because a lot of security practitioners use the word vulnerability to mean software vulnerability. That very term, I think, is very confusing in the standard. Is this something that is being looked at?
Yes, it is, and I think it's worthwhile to keep in mind that this is first and foremost an engineering standard, written primarily, developed primarily by engineers, automation engineers, process engineers, industrial engineers, and so forth. So their definition or their view of that word vulnerability is going to change. Is going to be a little different. Not change, but it's going to be a little different than what you might see in a pure a security text. Just for the record, the 62443 defines vulnerability as, quote, flaw or weakness in a system's design, implementation, or operation and management that could be exploited to violate the system's integrity or security policy. So you can see it's a pretty broad definition. It's more than just something that can be patched. Basically, what it says, it's a weakness in the system that could be a design weakness. It could be a weakness in that is a result of an oversight or a component that had a weakness, which then inclusion of the component introduces the weakness into the system. It's very much a systems engineering view of the term vulnerability. So that's important for people to understand. And one of the areas that is of considerable debate in this community, and we've all heard it, is that how is industrial system security different than information security. And this is one of the areas where that difference shows up. Our definition of vulnerability includes the textbook case of information system security, or the information system security definition, but it encompasses much more.
Okay, so we've been talking a lot about making the 62443 standards stronger, more broadly applicable. But the topic of the episode here has the word faster in it. In what sense are the standards going to become faster?
Good question. And if you say the word industry standard to almost anybody, one of the first things that pops into their head is standards take too long to develop. And by the time they're ready, we're past that. Or are they already, are they still relevant? And there's a lot to be said for that. There's a lot to be, we have to listen to that observation and that criticism. However, we also have to understand that standards by definition are meant to codify proven and accepted engineering practice. And so that takes a little time to figure out what that is, particularly when you're developing standards on a consensus-based, using a consensus-based process, as we are obligated to do, and we being ISA, as an ANSI accredited standards development organization, we have to be open and consensus-based. And particularly given the broad footprint that we're addressing here, as we've already talked about, the various sectors that could gain from this. Now, with all of that in mind, that's not an excuse. We have to look for ways to expedite the process. So virtually all standards development organizations that I'm aware of, the major ones at least, are exploring ways to do that. And you hear phrases like machine readable standards, electronic standards, things like that. How do we first of all, how do we get the material collected faster? And how do we get the consensus-based process to work more quickly? And then ultimately, how do we deliver it into the hands of people that need this guidance in a more digestible, form and in a more responsive manner? Now, in ISA 99, we've got some very interesting, I would call it prototyping or research work going on. We are very fortunate to have a few people who are not content with the status quo in terms of standards development and have some very special talents. And they are developing prototypes of tools to accelerate this process. So let me give you just a couple of examples of what they're doing. One of the things that you run into when you're dealing with a complex multi-part standard like 62443 is what I talked about earlier about consistency. Are we all using the same terminology? Are we all using a consistent view? When I say all of us, I mean all of the standards in the series. Are they all using a consistent view of fundamental concepts? And as the standards are written over a period of years or even decades, it's sometimes difficult to assess that. So these people that I mentioned are working on basically, I'll use the term very loosely, a database, the standard in the form of a database, that you don't read the documents as much as you query the database. And you can ask it questions like, show me the terms related to risk, what their definitions are and how they're related and how they make assumptions about or how they reference each other. You can ask questions like, show me all of the requirements that pertain to the principal role of asset owner and how those connect to another principal role, such as service provider. Another area that they're working in right now, which is probably one of the more recent endeavors of this small group of people, one of the things that takes so much time in developing standards is soliciting, receiving, and responding to feedback to improve the standards, the so-called commenting process. Well, they're automating that as well. So rather than having to fill out some form to send it off to somebody by email to go through a whole bunch of machinations and putting it in spreadsheets and analyzing comments and so forth. They're developing a tool to automate that. So when you get a document for review, it has a button at the bottom of it that says click here to comment. And it takes you into this database where you can put your comments in real time. And all of those comments are indexed and keyed, and such that when people come to look at them, they can pull them out and somebody can say, show me all the comments pertaining to clause 5.3 or pertaining to the risk definition or whatever. So this is ISA's, specifically ISA 99. I stress this is a prototype. So this is not something that we're using widely within the ISA standards community yet, but we are looking at this to see if its promise exceeds its cost to make this and thus having a positive value defined as benefit minus cost, that we could fundamentally transform the way we develop standards in ISA. I would characterize it as a space to watch. And I'm very optimistic that we can make some significant improvements.
Cool. So, we have that to look forward to. This has been great. Thank you, Eric, for joining us. Before we let you go, is there a thought you'd like to leave with our listeners?
Sure. The first thing, let me do, I was remiss in not doing this at the beginning, but let me thank you and Waterfall for giving me this opportunity to help get the word out. So that's very much appreciated. My message to the audience is very simple. We're all in this together. This being the challenge of addressing industrial automation, cybersecurity. We in the committee, in ISA in general, and in the ISA 99 committee specifically, and in IEC TC 65 Working Group 10, we're very motivated to continue and expand the 6443 series of standards to better cover the critical elements and give people practical, useful guidance on what they have to do to mount an effective, what I call an effective cybersecurity response. And so the message I would leave people with, if you're listening to my voice and you think, wow, this is interesting and he's missed something, or I've got some experience that might help, broaden the understanding and appreciation in this area, don't be shy. Reach out and contact us. Don't worry. We won't throw a net over you. We won't, we won't lock you up and make you make, multi-year commitments or anything like that. But reach out to us and offer your ideas and opinions. And we've tried to make that as simple as possible. I want to stress, first of all, that the ISA 99 committee is open to anyone. You do not have to be a member of ISA to be a member of any of ISA's committees. All of our committees are open to anyone with an interest and a knowledge in this area. And we tried to make reaching us pretty simple. You can simply send an email to ISA99chair, all one word, @gmail.com. I will receive that. My co-chair, Jim Gilson, will receive that. And we will get back to you to follow up on whatever your question. It could be an offer of an idea. It could be just a question about where do they stand, and how are they being used. We try to follow up on those. I probably get a dozen such emails a week, and we try to follow up on them as quickly as possible. The last point I will make is that as a sweetener or an incentive, our committee includes. We have over 1,000 listed members in our committee. A small portion of, typically my rule of thumb is the ratio of actively participating members in a committee to the number on the actual roster is 1 in 10. And we hold pretty close to that. I'll say for the sake of argument, the 100 or so people that are really actively contributing includes a whole lot of independent consultants. And when I say independent, most of them are now working for themselves because they're like me, they're semi-retired. And we provide advisory and consulting services in this area, in some cases through a company, but a lot of cases as an independent. So, again, if you want to join a community where there's a lot of very smart people on this subject, you'd be hard pressed to find another community as rich as the ISA 99 committee. So come on in. The water's fine. We welcome any and all contributions and any questions that you may have.
That was Eric's last word. Andrew, how about yours?
Well, I like this episode. I learned from Eric. I mean, a couple of sort of long-standing concerns I've had with the standards he's addressed. He said, look, a lot of people are worried about the definition of security level aging out in terms of the capabilities of the threats out there, and it's being addressed. He said, interpreting the same rules across industries is confusing, and it's something that they're planning to address with these industry specific profiles. So, I was happy to hear that it's not just me, that other experts have these concerns as well, and that they're being addressed, and that I can look forward to an opportunity to comment on what these gurus are working out with in the committee meetings when the drafts are published in the months ahead. So, I'm happy to see progress.
Well, thanks to Eric Cosman for speaking with you, Andrew. And as always, Andrew, thank you for speaking with me.
Always a pleasure, Nate. Thank you so much.
This has been the Industrial Security Podcast from Waterfall. Thanks to everyone out there listening.